Place Value, Volume 2, Exploring Decimals just for you on Math Visions with your math jockey, Mitchell Weaver. Decimals are like fractions, where the denominator, number on bottom, is always a multiple of 10, such as 10, 100, 1,000, 10,000, etc. In decimal form, we round fractions such as 4/17, 2/5, and 1/3 to the nearest 10th, 100th, 1,000th, etc., since most conversions are not perfect. In our example, 2/5 is the only one that converts perfectly. And remember, we do not separate groups of digits to the right of the decimal with commas. I've written 0.63 as well as 0.063, since both numbers have the same value to the left of the decimal, in this case 0 or blank space. We look at the digit immediately to the right of the decimal. Our first number has 6 just to the right of the decimal, and our second number has a 0 just to the right of the decimal. Therefore, the first number is bigger, even though it has fewer digits to the right of the decimal. The amount of digits to the right of the decimal does not matter the way it does to the left of the decimal for determining value. Our first number reads as 63 hundredths, and the second one reads as 63 thousandths. If you noticed, thousandths are smaller than hundredths, the opposite of thousand and hundred without THS. I'll visualize the difference. If you noticed, I drew two grids of equal size. However, the one on the left is divided into 100 large pieces, and the one on the right is divided into 1,000 small pieces. This is the equivalent of hundredths to the left and thousandths to the right. If we fill in 63 squares in each grid, you'll quickly see that 63 hundredths is indeed larger than 63 thousandths. If you noticed, we call numbers to the right of the decimal based on the digit that is farthest right in that number. Let's try another one. 0.076 and 0.13. What do we do next? If you said, look at the digit just to the right of the decimal, you're right. Now we see that our first number has 0, one space to the right, and our second number has 1 in this position. Therefore, our second number, 13 hundredths, is greater than 76 thousandths. Our visualizations drawn to scale verify this. Now, we'll change the first number to 0.138 and leave the second number alone. Which one is more? Since the digit to the left of the decimal is 0 for both numbers, we'll look at the digit to the right of the decimal. We see they're the same. Therefore, we check the next digit in both numbers. We see these are also the same. So we move over one more digit to the right. Now, we see that the top number has 8 in the thousandths place, and the bottom number is blank in the thousandths place, which is the same as 0. Therefore, our top number, 138 thousandths, is marginally larger than the bottom number, 13 hundredths. I've used red squares in the thousandths grid to show the slight difference in value between 138 thousandths and 13 hundredths. Now I've placed both sets of shaded blocks next to each other for a better view. Finally, how about 5/6 as well as 5/6.13? If you noticed, they both have two digits to the left of the decimal. Furthermore, each number is the same left of the decimal. What do we do now? If you said, look at the digit just to the right of the decimal, that's correct. Our first number is blank just to the right of where the decimal would be, so we'll treat that as 0. And our second number has a 1 just to the right of the decimal. This means that our second number, 56 and 13/100ths, is slightly more than 56 by itself, just like $56.13 is more than $56 even. Well, that's a wrap for me. Thanks for watching. Don't forget to check out my knowledge building exercises, link below in the description. I look forward to meeting with you right here next time on Math Visions.